सर यूट्यूब लाइव है सर, सबको बैठने के लिए कह दीजिए एक बार।
Hello. Good morning, respected professors, researchers, delegates, participants, ladies and gentlemen present here, and our alumni joining us live from all over the world. I am Ariba Bashar, and I welcome you all to the day 2 of the plenary session of the International Conference on Emerging Computational Intelligence 2023. This session is intended for the researchers around the globe interested in the areas of artificial intelligence, computational intelligence, machine learning, cybersecurity, fuzzy logic, blockchain, cloud computing, Internet of Things, wireless sensor networks, and many more. The theme of this year's conference is Emerging Computational Intelligence, and we have an impressive lineup of speakers who will be sharing their insights and perspectives on how it can be leveraged for positive impact across different industries, from healthcare to finance, and from education to environmental protection. It has the potential to bring about significant change for the better. Now, I invite the guest of today's function with a request to come on to position and occupy the distinguished chair. I consider it a great honor to welcome Professor Qazi Mazhar Ali, Professor at the Department of Statistics and Operation Research and former Dean of the Faculty of Science, Aligarh Muslim University, to preside the session, and I request Professor Ali to please join us on the dais. Thank you, sir. Now, I welcome Professor Ajit Abraham from Machine Intelligence Research Lab, USA, who has joined us live. Professor Abraham is a scientific writer and an eminent researcher. He is our keynote speaker this morning. Sir, I'd love if you could please wave your hand to the audience. Thank you so much, sir, for joining us. I feel privileged to welcome our second keynote speaker this morning, Professor Yatindranath Singh from Indian Institute of Technology, Kanpur, who is also available with us online. Professor Singh is a distinguished scientist and an acclaimed researcher. I welcome you, sir. Sir, it will be great if you could wave your hand to the audience. Thank you so much, sir, for joining us. Ladies and gentlemen, it is a great honor to welcome our third keynote speaker this morning, Professor Mohammad Abulesh from South Asian University, New Delhi. I request the Honorable Professor to join us to the dais. Thank you, sir. Next, we look forward for the presence of Professor Tamanna Siddiqui, Department of Computer Science, Aligarh Muslim University, onto the dais. Thank you so much, ma'am. It is my privilege to invite Dr. Shafiqul Abedin, Professor at the Department of Computer Science, Aligarh Muslim University, to grace the dais. Thank you, sir. May I now request Professor Tamanna Siddiqui for a welcome address and to introduce the dignitaries.
Thank you. Bismillahirrahmanirrahim. Assalamu alaikum. A very good morning to all of you. Respected chair of this session, Professor Qazi Mazhar Ali Sahab, former Dean, Faculty of Science, Aligarh Muslim University, Aligarh, esteemed speakers of this session, Professor Ajit Abraham, Director of Machine Intelligence Research Lab, USA, Professor Yatindranath Singh, Professor Electrical Engineering, IIT Kanpur, Professor Mohammad Abulesh, Professor and Chairperson, Department of Computer Science, South Asian University, New Delhi, Chairperson and the convener of this session, Professor Asim Zafar, General Chair, Professor Muhammad Obedullah Bukhari, all organizing chairs, dear students and participants. On behalf of Department of Computer Science and as a General Chair, I am Tamanna Siddiqui. It's my great honor and privilege to extend a warm welcome to all of you. It's a plenary session 2 of the International Conference on Emerging Computational Intelligence organized by Department of Computer Science, Aligarh Muslim University, Aligarh. I welcome you all with the greatest reverence and highest admiration. Thanks everyone for joining us today. I hope you will enjoy this session. First of all, I proudly introduce the chair of this session, Professor Qazi Mazhar Ali Sahab. He is a renowned professor in statistics and operation research at Aligarh Muslim University. He is the former dean of our faculty who contributed a lot to our department through his rich knowledge and guidance. He has vast experience in teaching, research, and administration. He is a topper at UG and PG level and obtained his PhD degree from University of Oxford, UK. He has also provided academic services to foreign countries like United Kingdom and Bahrain. He has versatile knowledge, worked as chairperson of Department of Remote Sensing and GIS Application, Director Computer Center, member in charge Telephone Department, warden of the hostel, and many more. As an academician, he has done a lot. He has supervised many PhD scholars and published research papers in very reputed journals. He worked as a principal investigator of many research projects. He obtained international recognition for his research work from the United Kingdom regarding his work on image analysis technique for art style. Sir, I'm indeed happy to welcome you today. I'm delighted to introduce our first speaker, Professor Ajit Abraham, Director of Machine Intelligence Research Lab USA. He has more than 1,300 publications, 50,461 citations, and more than 15 research projects. He is also a reviewer and editor of 36 reputed international journals. He obtained his bachelor's degree from University of Calicut, Kerala, master degree from Nanyang Technological University, Singapore, PhD from Monash University, Melbourne, Australia. He has more than 30 years of teaching and research experience. His primary research is developing machine intelligence using hybridization of function approximation methods, approximate reasoning, global optimization method focused on big data analytics, information security, web intelligence, decision support system, and Internet of Things. He has collaborated with researchers from top universities like MIT USA, Harvard University, and Oxford University, UK. He has provided his academic and research services to many countries like USA, Czech Republic, Norway, South Korea, Australia, Malaysia, Ethiopia, Singapore, Sudan, Kazakhstan, Italy, Poland, Hungary, Spain, France, and China. He will surely enrich our audience with incredible knowledge and profound experience. A hearty welcome to you, sir. Our next speaker is Professor Yatindra Nath Singh, Professor Electrical Engineering, IIT Kanpur. He has done his BTech from NIT Hamirpur, MTech from IIT Delhi, PhD from IIT Delhi. He got IETEMN Saha Memorial Award for Best Application-Oriented Paper. He was honored with AICTE Young Teacher Award in 2002. He has supervised more than 15 PhD theses, 3 MS research theses, more than 25 MTech theses. He contributed 32 research projects, many publications and patents, and has more than 1,600 citations. His research interests are peer-to-peer networking, optical networks protection and restoration, optical pocket switching architecture, pocket and circuit switching, wireless infrared communication, optical communication, and many more. He has vast teaching experience, research and administration experience. He worked at IIT Roorkee and various positions at IIT Kanpur, mainly Dean of Digital Infrastructure, Head of Computer Center, Chairman of CEMMC. Professor Singh, I am glad to extend a warm welcome to you. Now it's time to introduce our third speaker, Professor Muhammad Abulash, Professor and Chairperson of Department of Computer Science, South Asian University, New Delhi. Professor Abulash, I'm extremely happy to welcome you here because I have a special bonding with you. We work together as a colleague of Jamia Hamdard, New Delhi. Professor Abulash is also working as acting registrar of South Asian University. He obtained his PhD degree from IIT Delhi. He has more than 24 years of experience in academics and research in many universities like Jamia Hamdard, Jamia Millia Islamia, New Delhi, and King Saud University Center of Excellence in Information Assurance, Riyadh, Kingdom of Saudi Arabia. He has published over 130 research articles in international journals, books, and conference proceedings, including IEEE and ACM transaction. He has more than 2,000 citations. His research focuses on developing innovative data mining, machine learning, and network analysis techniques to address real-world social and industrial problems. He is an editor of many reputed international journals. I am sure all three speakers will enrich our audience today. Once again, the heartiest welcome to all of you. Thank you.
Thank you so much, ma'am, for welcoming and introducing our invited guests. Ladies and gentlemen, this is Nabila Masroor, and it is my pleasure to call our first speaker, Professor Ajit Abraham from Machine Intelligence Research Labs, USA, who has a wealth of knowledge and insights to share with us. Please join me in welcoming Professor Ajit Abraham. Over to you, sir. So, ladies and gentlemen, I am extremely happy and excited to invite our speaker, Professor Yatindra Nath Singh from Indian Institute of Technology, Kanpur. I request Professor Singh into sharing his words of wisdom. Over to you, sir.
So thank you very much. So thank you everyone. And yeah, Ajit probably missed out. He actually exited from the system. So the sequence has changed now. So I will be
It's
talking
okay,
about
sir.
my journey in abstract. My voice is coming, I think. No?
Yes, sir.
Okay, great. So uh, just a minute. Yeah. So now I will be able to see all of you also. So this is basically the work which I am actually describing has come out of one of the initiative in which Professor Bukhari and Professor Asim actually was also participating at one point of time. Then of course it was discontinued. I will tell the storyline. And then went on to a different journey from where the actually peer-to-peer networking started. And this was a wonderful thing. I discovered a lot of stuff and also figured out why people don't work in this area and who actually all work and what are the implications of working in this. And now it has actually culminated into a company. So this is called Yerna Systems Lab. So I am mentor to that. This is being now run by my PhD students who have graduated or who are working in the lab. So the whole lab actually is now involved, all 19 PhD students who are there in my lab currently. So we are now into a commercial venture for this, as well as for some other embedded stuff, which can also be done. So that's why now there is another affiliation which has got added to this. So this has happened in January once the institute gave the permission. And so we are actually operating it from our own lab. So let's now begin with the thing. Yeah. So the story goes this way that when we were doing that work, that time we were always writing software for the servers. Okay. And then we were writing a lot of code which people used to run in browsers and access the server to do a lot of stuff. One of the simplest thing which I did was LMS, which we called Brahaspati that time. And it was Brahaspati 3, which we did when Professor Asim and Professor Bukhari also joined the project. It was a national mission. 9 universities were participating with IIT Kanpur as a lead. One of the partners was AMU also in that case. They have actually done an election management system, if I remember correctly, which we have used extensively. But the peer-to-peer form of that still has to come. That has not come. So the web-based system, well, that is available in open access currently. So remember, any such system, and in fact, normally whatever you have been using is always a client, and you are always communicating to a server. Even two clients, when they want to talk, you are dependent on the server. If there is an outage of the server, you are just on your own. You can't do anything. Okay. For example, if a Gmail server goes down, you can't send mail to each other if you're connected via Gmail. So that's basically a conventional system. We call it a client server model, which is very prominent. In fact, almost everybody thinks this is the way to do the things, but this is not the only way. The internet originally was never designed to work in this fashion. This somehow actually has happened because in any capitalist system, the corporations has to come in, and then those corporations will own the servers, they manage it, so it will become a business strategy. So, and there were of course a few more reasons because of which they actually survived for a long time. But now, since the migration has started happening, this is a big. Almost all corporations have to now make a big strategic change because of this changing phenomena. But of course, this needs legal implications are there. The legal clarity is there. Law permits this. Probably this is going to happen. Otherwise, you will probably get into a mix where some partially peer-to-peer systems will keep on running and most of them will still be client server. Okay. I will probably avoid that legal part. Those of you who are aware of Tor already are knowing that what are the legal hassles which exist with that. In fact, the same thing is with Telegram. Telegram is in a sense peer-to-peer, but not fully peer-to-peer. Okay. So normally one of the big challenges in client servers, things are very easy actually. You simply have a login and password. This is the first challenge which you get whenever you are actually using a client server system. You have to use authentication. Life is very easy here. You simply have something called challenges, and challenges have to be responded to. It's mostly in form of login and password. So login is basically user ID. I should not call it login. It's a user ID. So you go to a Gmail server and you put your Gmail ID, and then it will ask for a password. If you can give a password, the guy will authenticate you. And of course now, because this has become a pain in neck because of cross-site scripting, all other kind of attacks, okay, Trojans coming into the thing. So people have come with the two-factor authentication. So an OTP will also come on your phone or on another email ID. So basically using multiple devices, multi-factor authentication we call it. But this is not the only option. There is another option which is not very commonly used. We use it only for verifying if the servers are genuine or not. We don't use it to verify clients. Okay. But principle is very simple, that if you want to do it that way, you don't have to give your user ID is part of your certificate actually. So server knows from your certificate which you present to the server that yes, you are the user actually corresponding to that user ID. And it also has a public key. And new server has to simply do a kind of a mechanism, a protocol. We call it secure SSL, secure socket layer. Essentially, the variation of that is being used in all the places. The variation which I will tell is what is used in Tor. Okay, Tor is the onion router. The Tor browser.org, you can go and download if you want to use it. But remember, in some countries, this is illegal. This is not legal to use that. Okay, so basic verification is whether the other side does hold the corresponding private key or not. Okay. So the public key which is present in the certificate, and certificate normally is going to be signed by some third party, which is a trusted authority, on which both sides actually will have trust. So that's why the certificate will be accepted. Okay. So this understanding is required to figure out what we have been doing now. And of course, this is a very basic thing, which I think a lot of you may be knowing it. If you don't know it, you have to just understand it. So there are two things people normally think. There are two concepts in any cryptographic system. One is the encryption, basically hiding so that the guy who is in between should not be able to see the information. Second thing, he should not be able to tamper with the information. And the receiver should be able to verify genuinely who has actually created the information. So first part is encryption, second part is digital signatures. So normally you will have a content, you will have the receiver's public key. Remember, encryption is always done with the receiver's public key. Your keys are not important there. You just use that for encryption, send the encrypted content all the way, and this can be decrypted using private key. This is a very simplified thing. Actually, this is not done, especially for long files or very large amount of data, because public key based encryption and decryption is costly affair in computing. So normally what you do is you actually take a symmetric key, do the encryption with that, and that symmetric key itself is encrypted with the receiver's public key. So encrypted key and encrypted content both are sent. So receiver will use the private key to retrieve the symmetric key, and that symmetric key is used for retrieving the content. This is far more efficient process. So this is what we also have been used, but in our case, the receiver is the sender itself. This is used for a distributed file system implementation in a peer-to-peer cloud formation actually. But this is the actual variant in all commercial systems is being used. Second one, you take a content, you use a private key, compute a signed hash, and send the content. Now this content is still visible to the people. All of them can know the corresponding public key is supposed to be known to the public. They can actually use that and verify if the content is tampered or not being tampered. That's a digital signature. You can combine these two if you wish. Both are feasible. And one of the important properties of this public-private key pair, this is of course is being also to use what we call random numbers, whether the other people actually have truly generated a random number or not. When one is supposed to generate a random number, he may not generate it actually. So that leads to an attacks. So we generally use a mechanism which is public and private key pair generation, and using the public key itself to generate the node ID. or for example any random number. So this is a very standard technique used in almost all systems. So our system also uses that. Okay. Important thing is that if you know one, you can't find the other. You have to generate both the things always together, and there is only a random process by which it is done. There is no deterministic process. So you can't determine that for a certain public key, what should be the I will be able to generate public-private key pair, and the public key will be the one which I want. Now that is not going to happen. That's not possible so far. Maybe in future, if some mathematician figures out a way, then of course our whole cryptographic security systems will actually crash. We have to now invent new ways. So probably people are working already on that, but software systems are still depending on this all across the world. And so first thing is that how you get your certificates. So this is the system which we have been using. This is not the one which is used by you if you are buying a certificate from say eMudra or some other certification agency. So they go through a different process. What you use for running a company or filing your IT returns, so it goes through a different process. So this is the one which we have implemented. We actually have a authentication server. That's the only server which we have, which can be very small machine, and a user has to come once in a year to that, because we also would like to collect the money. Okay, because we have to run the show. So and that time we just sign his digital certificate. After that he is on his own for all the kind of things which he would like to do with the application. So in this case, generally a user will generate public private key pair. He will keep the private key with himself. Private key is only with himself, generated by him. It is never shared with anybody. That's a fundamental. And he will create a certificate which will contain his email ID, or maybe it can be his mobile number, is the public key of which he has generated, and he will sign with his private key. Remember, the public key is there, so I can verify the private key, the signatures. And is being sent to the certification authority, in our case auth server. And auth server will normally verify two things. First, the guy owns the email ID, so it will send an email over an OTP. OTP will be sent over an email, which will be received by this guy. And secondly, he will send a random string, which will be encrypted with the public key back to the user. So user will be the only one who can decrypt it. And he will send OTP and this random string both back to the server. So we can actually do the complete verification of the user side and sign its certificate and send it back. Now there is a trusted channel which is being created between user and the server for this. This is again a variation of SSL which we have been using. This is not exactly the way the SSL operates. Okay, so here you can actually see there is a client A and server B. So principle is pretty simple. Only B will have the server. This happens when your browser is connecting to Gmail, for example. Okay, Gmail has a HTTPS, so it has a security certificate. But as a client, you only have login and password. So your browser does not have any certificate actually. Though you can install it if you can buy one, and you can install it in your browser and you can authenticate with that. That is possible. Okay. So B will, but I am actually looking for a normal process. So the B will send a certificate. Client simply has to verify whether certificate B is actually signed by some trusted authority or not. Once it is accepted, it will send a random number, which I call it rand A. And this is going to be encrypted with the public key. So can only be decrypted by the private key. So only B can retrieve it correctly. Nobody else in the world can do it. So once the rand A is figured out, rand B, another random number is generated. And a symmetric key is being created out of rand A and rand B combination. And rand B is sent back as it is. Hash of the key is also sent actually. Remember, hash is a cryptographic hash. So if you know the output, you can't figure out what was the input. So it's from an infinite set to finite set mapping, technically hash. So normally we use SHA-256 or SHA-512 or even higher actually. Secure hash algorithm, that's what the SHA stands for. So rand B need not be encrypted actually. This is the exact algorithm used in Tor while creating multiple secure tunnels between a telescopic extension which is created there. Anyway, I'm not describing Tor. Maybe in some other lecture I can describe about Tor, the engineering inside it. So once both guys now will have the correct rand A and rand B if server B is properly authenticated. So this what we call secure channel, this symmetric key is what creates a secure channel. And that's why when you communicate with Facebook or Google or Twitter, your information cannot be read while it is in the transit. It is only can be read at your end or at the server, nowhere else. Okay. So this is a basic thing. We now actually have modified, this is the remaining process by which the certificate gets signed. So I am skipping this. This is how the two people can authenticate each other. They don't require any server. Remember, in peer-to-peer systems, this is a capability which is required. So this forms the fundamental basis to understand peer-to-peer. So in this case, both A and B will have certificates and they have to mutually authenticate each other. It's a mutual authentication. That's a key word here. And they have to create a secure link between them. And this secure link symmetric key should be independent of the previous session and no other future session should depend on this. So that's why it's through a random number generation process. And I assume even if one party generates a truly random number, nothing is going to happen. Every time there will be a different symmetric key. So they will exchange the certificate for each other. They will verify certificate's validity by looking at the digital signatures by certification authority, or in our case, authentication server. A will send a random number A through encryption through public key. This is a costly computation, but it is done. Other side, B will retrieve the random A. It will generate a random B, and B both are being sent A in encrypted fashion in the back. You need not, you can do the other way around also. The earlier algorithm where rand B is not encrypted. And both now will be, if the rand A and rand B are known to both correctly, the both of them have mutually authenticated each other. They can combine this and create a key, and they create a secure channel. So Tor actually creates multiple thing that by default, I think it's a 4 encryption layers being created one in another. That's also another beautiful engineering piece where without adding any extra overhead byte, they can do multiple times this thing and they can figure out when the you are in the innermost tunnel. We have not done that onion implementation in this because that's again illegal here. So now this is the domain verifications. Normally you do, the certificate will contain the domain. So you do in HTTPS the similar algorithm to do the verification. So now coming to peer-to-peer, the ones we understand the basics. So why this has actually happened is because earlier days machines with good compute power were very costly. They were very few. There were have to be only few of them. All other people have to access it remotely. So they become servers. Other people have to use low-end machines to become clients. Bandwidth was scarce. It was not pretty much available to everybody. So you keep servers at a high bandwidth points and other clients will connect with a low bandwidth. And it was a very reasonable to have those kind of things. You ended up in having FTP clients, Telnet clients, HTTP client, all kind of things actually have been built and corresponding server daemons were actually written. Okay. But of course, nowadays you can get your server daemons can also run on your client machines. It is actually done. So in fact, truly that the one requirement which was there for peer-to-peer was in telephony. So telephony was never migrated to the internet world because of that. It remained a separate network, circuit switch network. In fact, two words were having two different set of protocols. One was SS7, which was used in telephony, and one was TCP/IP, which was used in internet. And there were two different things. One was electrical engineering, other was computer science. But now the world has changed. Everything is now electrical engineering, the whole networking. So this was truly a peer-to-peer connection created through a control plane. In fact, now internet has was not having a separate control plane. Now internet has started having separate own control planes. We call it SDN. So SDN network or SDN layer actually is being separately done. Most of the networks are configured that way, smaller size. Large size, we still have to go to a distributed thing. Okay. So packet switching was incapable of giving this required delay limits in earlier days because of low bandwidth requirements and low processing capacity of the nodes. This has changed a lot. Now these two things actually have changed the whole technology, the whole paradigm, the whole computing. In fact, the whole curriculum has changed because of that. And these are still changing. One thing is that your machines have become extremely powerful. Now the handheld mobile phone will have 8 cores of CPU running at 2 gigahertz. You will have 1 terabyte of flash disk on that, and maybe RAM of 16 GB, which is, these are like supercomputer specification of yesteryears. So you are actually holding supercomputers of yesteryears actually. The bandwidth is pretty high now. You actually can easily go with 1 gigabit per second wireless speed is possible actually with MIMO. Uh, and with fiber optics, if you have connected to your home, you are already on 10G. In fact, most of the campuses are on 10G network now. So essentially, the concept of server has to be now done away with. Uh, in fact, if you want to still retain servers, they need to be scaled up to a much higher capacities. So in fact, the way the companies or corporations actually have handled this, they have created as not one server but multiple machines put together to form a cloud. Okay. So this is a very common thing. In fact, these CDNs, content delivery networks, actually have came up. Akamai is actually doing the similar thing. Google maintains a desktop kind of machines as multiple places distributed, and they form their own server clouds. Technically, they are using the same technology, which is called peer-to-peer network, but it was not with the users currently. So slowly migrating into that domain. And one of the, I think, the flagship projects which have been very successful is SETI project, which you can call a peer-to-peer system actually, where you download a screen, the display thing. When you are not working, that start computing for the some job which will be assigned to him by the city command center. This for search for extraterrestrial intelligence. They are trying to essentially get the unlimited compute capacity which is being used for doing computation. Okay. So the idea is that we can actually put all client machines together and create same QoS as given by virtual machine on a server cloud. Okay, and you won't be requiring data center. One of the good things. Resources will scale linearly with users. As user increase, the resources also increase, and you don't have to provision for services beforehand. So it's a kind of a green technology. The lower carbon footprint is going to be there in this case. Okay, but we have to build up efficient mechanisms. That's what we had done. So it's not that it was not there. In around 2000, we had Skype. This was peer-to-peer system in the beginning. Later on, it has been acquired by Microsoft. And now it is basically a server-based system. Currently, it's connected to a server cloud. It's not a peer-to-peer anymore. BitTorrent was very popular. It was a centralized index. There was no distributed thing. You still require indexing server. DC++, Napster. BitTorrent now do have a version which works on distributed thing. Napster is now closed actually. So, but we have now gone further from here. We don't want this system to be present. So in fact, what we did is we started, now this is my story. We started around 2003. We built first Brihaspati LMS, then Brihaspati suite of products. This was supported by Government of India. It was basically Ministry of Electronics and Information Technology and Ministry of HRD. Till 2015, the support was there. After that, there has been no support. We are on our own. There were a lot of products which were added, and this was kind of an option for IT systems and institutes. Unfortunately, they were in open source. Academic institutes either way, we goofed up. Ultimately, the companies are actually moving to open source, but software is still available. But most of it is very, it may be sluggish. The scaling up was probably an issue. So I migrated from here and then moved to peer-to-peer, which probably is a much better alternative. It auto scales, provides functionality, and it can form the user cloud. And the B4 or Brihaspati 4, that's what we have been working on now. So this was actually where the latest B4 client and B4 server code was available till December 2022. And after that, once we formed the company, we have taken it out from the open source. This anyways, I am actually pointing it to only Java-based code, but this is what we have done so far. Now we are actually have been working with Flutter and Dart. so that we can actually give it on Android, iOS, as well as Windows and Linux, all four of them at the same time, which is a very different challenge, because for the first time we figured out there are no threads in Dart. We have to use async await kind of thing. So it's a different engineering design, but we are going through that. So maybe another 6 months down the line, we will have it. That's what the company is doing. So the principle was that, but one thing which I got confidence on, that you can just take any kind of students, let them do the things, they will make mistake, and through iterations we will be able to rewrite the code, replace it. So there was a continuous churning which was happening. It was technically agile method, but with no time limits or no time bindings, and we were able to build up and maintain the products, and they were very complex at some point of time. But that confidence has now paid off, but now it's much more structured system which is in place. Yeah, so this is how the system is going to function. Normally in indexing server based system, you will have an indexing server. Everybody will now register their nodes. This I am talking about telephony, for example. So your phone number and endpoint address, which is your IP address, will be actually, and port number will be registered with indexing server. So you want to make a phone call, go to indexing server, find out your friend's phone number using that, the endpoint address, then directly make a connection with him. That's how the SIP telephony, the current day telephony, actually operates in internet. Current day telephony is only based available on internet. The older yesteryear circuit switching is gone. It's no more available. Okay. So we have modified this. We said we need not do it. We can actually do distributed indexing. Okay. Each node will store only very few, one or two actually indexing entries, and each node need to generate a node ID. So normally different systems have different size. For Brihaspati 4 we use 160-bit, and incidentally the SHA-1 can be used to create the hash of anything to create a 160-bit. So that gives us a kind of a direct function which we can use. Each node will store some of the key values. So key, remember, here is a mobile number and value will be the endpoint address. Now the same paradigm can be modified for other services like DFS or distributed computing, maybe creating a supercompute cluster by using extra compute available at the nodes. The messaging part, there actually I will list down a lot of applications. So basically we figure out who is responsible for which particular key. This has to be figured out. So we take key, we do the hashing of this, compute the cryptographic hash of the key, generate a point in the node ID space. Now this is how it actually fundamentally looks like. These are the actual nodes which have got their node IDs. They are in the node ID space. Any key when being hashed is also going to be in some place in the node ID space. So whichever is the closest node ID is its root node. So he is going to be responsible. If this guy dies off, the next closest guy, again the repartitioning will happen automatically, and the next guy will actually start holding on to that particular entries. So you don't require servers, all nodes together actually can do this job. So we actually are using B4 and another algorithm which is our own invention, which is called tapestry and chord combination. Tapestry and chord individually are better known algorithms. They are essentially two extremes of the same thing. Tapestry is midway, Kademlia and chord are the two extremes of the tapestry algorithm, and with a beautiful distance metric formulation. And of course, the problems people will always ask, server is always there, corporation is giving a guarantee, but how you will give the guarantee that the things will not be, a node will not die off? Yes, node will die off, node can exit from the system, the guy can turn off his own machine. We need to make some mechanisms. We need to ensure that every key value pair is at multiple nodes. And if a node exits, who is responsible for one of those entries, another duplicate copy should get created. So it's kind of a living organism which is moving across the living nodes all the time. And this is algorithmically possible. We have done that. Okay. So possibly if a node suddenly exits, it's automatically taken care of. When he comes back in, it's again automatically rearrangements can be done. So we have been using what we call consistent hashing for doing this job. Or you can even do rendezvous hashing. Any one of those two techniques can be used. So we have been working with the consistent hashing, the way I think all developers all across the world have been doing. So normally what we do is we just take the key and add these two strings. That's a simple principle. We compute the hash, we get two hash IDs, therefore two different root nodes. So you can actually have as many copies as you want, and they can start republishing cyclically with each other. That's a principle which we use. Okay. And they need to be republished before the expiry happens so that the content can move. That's the algorithm. Remember, deletion is very difficult. It's always through expiry process. Explicit deletions are very difficult in any kind of peer to even, even on Google Drive, if you delete it, is actually not deleted. It remains there. It automatically purges after a timeout period. Okay. But there is a corresponding republication which keeps on happening to the entries which are already indexed. So same thing happens in IPFS, same thing happens in your Telegram. Okay. So now the only entries with root nodes will persist only because of periodic republishing. So that's a beautiful algorithm which goes in it. There is absolute expiry time, and that time the entry will normally remove. So in our system, it's every 10 minutes we are actually doing republishing, and every 6 months we are actually is a purge time. So before that, if your file system is there distributively, you have to do a reset of the entries actually. So that can be done. So it is done in our system. There are also kind of, for example, IPFS, you put a movies there or books. In fact, if you go to libgen.is and search for a book, you have an option for downloading from IPFS. This is again an illegal site. So be responsible on your own. So when you download from IPFS, you can download movies, for example. If a movie is being pushed into it, it's being fragmented and distributed across all the world. And when you download, everything is brought down, stitched together, and then you download it. And this, there is no expiry time there. So in fact, we have implemented, we call it a universal file system, where we actually have an expiry entry. The moment you access the file, expiry is reset every time whenever it is accessed. So advantage of this is the content which is not accessed for say 50 years will because birth and death, both processes have to be there in the system. The design is that way. So normally for that, we have kept a timer value or expiry time for 5 years in our system. Okay. Now this is the typically the how the routing will happen. We call it a logarithmic partitioning mechanism actually. The whole node ID space is partitioned this way. So if you are actually sitting here, so there is one half in which you are not present. So you will find out this node which is closest to you, maybe in terms of RTT or geographic distance or something else. You will maintain at least one entry. Then the remaining this half you will further divide. So this blue color you will have one entry from here. So remember, it's you are going to maintain log 2 of n, where n is a total node ID space size. With 160-bit node ID, Kademlia uses 116 node ID entries. Okay, log 2n is 160 because 2 raised power 160 is the node ID space size. So this is how the routing tables are maintained by everybody. The protocol is very simple. Periodically exchange the routing tables, okay, with your neighbors, and whatever new nodes you come to know, you just keep on finding out who are the best candidates and keep on repairing your routing, keep on updating your routing tables. So normally this will always get stabilized unless people start moving here and there and RTT will change. But this is a wonderful thing which if you simulate it, it looks very good if you see it on the screen. This is the basic algorithm. I am not describing tapestry chord. Okay. So for that, the patent is still pending. Unfortunately, India, the patenting is difficult for algorithms, but we are still trying to sort it out. So this is basically the chord one, which is always taught in computer science courses. I think all the students, all faculty must have taught it or must have been taught by somebody else the same thing. So here actually all node IDs, which are truly randomly generated, I will tell you how that is done, is being arranged in a circular fashion. And you want to search for any key, for example, mango, you compute the hash. If value is 8, so 9 will become responsible. Okay, here the rule is the lowest value of the node ID, which is greater than or equal to the hash ID, will be the root node. Okay. There is a distance metric formula. I have not written it here. That also can be used. So for managing multiple copies, you do copy 1 and copy 2. You may actually end up in 2 different root nodes where the copies are maintained. Okay. So very simple thing, whenever you want to search for a key, find out who is the root node. Once the root node information comes back to you, directly connect with him, peer-to-peer connection, and then search for the key. Key hash value, get the key value pair, get the value, and then do the processing. You can do any kind of, you can do voice over IP call also with this. So we have actually done a voice over IP call system using Java that is currently in use in Army for internal actually communication for theirs. Okay. So this is typically, now the problem is if key and value both are going to be there in the index, there is a problem that when key is going to be published, somebody else can actually figure out what the key is when it is being transiting. Okay. So we need to compute what we call hash of it and always use the key as the hash as a key. So, and of course, if it is IPFS kind of system, UFS, the hash of the whole content should be used as a key. That's a principle which we have been following. IPFS also does exactly the same thing. It's not that simple. It's actually being fragmented. We create a descriptor file first. We fragment the thing and all fragment information inside it. Hash of that essentially is used, not the movie files hash. This is the mechanism by which we ensure that random node IDs are always generated, because otherwise you can build up a denial of service attack actually. So you generate a public private key pair. Sorry, this one is for how the content is being encrypted. So this is a symmetric key which is encrypted with the public key. Content is encrypted with the key, that is what is sent. Okay. And the key will be the contents hash actually. That's how the key and value pairs are being generated in UFS system. For this one, for denial of service attack, we actually generate public private key pair. For every node, this is done. In fact, you go to sync thing. I will list a lot of actually applications. This is done exactly the same way. So public key is hashed, you get a node ID. And that node ID and public key is put. Hello. Yeah, done. Signal that I think time is limited. So I will just actually skip this. You can actually look at my MOOC course for actually learning about this stuff. So these are the basically a few of the things, peer-to-peer systems, which you can actually try. Some of them are available for free. B4 is not available for free as of now, but it will be coming in form of an app. So I'm skipping this. Not many slides are there now. We have certain innovation. These are the applications which will come ultimately: VoIP, storage, messaging, mail, overlaid multicasting, live streaming like Netflix kind of thing, video on demand, distributed search. There is a peer-to-peer web concept. You don't require web servers here. Okay. A compute cloud and collaborative authoring. So we are going to target all this stuff in time to come. So you can contact me if you want to do something regarding this technology actually. And of course, we already have, it has also become part of the blockchain, underlying layer of that. So we have been also working on that thing. But anyway, because time is short, so I am going to close here. So thank you very much, everyone. So I can take up questions if there are any.
Thank you so much, sir, for sharing your experiences and knowledge with us. Ladies and gentlemen, we have Professor Ajit Abraham with us now. It is. Okay. Okay. Do you have any questions from Professor Yatendranath Singh? No questions. There are no questions, sir.
Okay,
Thank
done.
you so much, sir.
Welcome.
Ladies and gentlemen, it is now my pleasure to call our next speaker, Professor Ajit Abraham from Machine Intelligence Research Labs, USA, who has a wealth of knowledge and insights to share with us. Please join me in welcoming Professor Ajit Abraham. Over to you, sir.
Are you able to see the screen?
Yes, sir.
Am I audible?
Yes, sir.
Perfect. So very good morning to all of you. Actually, there was indeed a small hiccup in the beginning. Actually, I was using Google Chrome and then it was not allowing me to present the screen. I guess some recording security issues. So I had to go out, and then once I came back, it was not letting me in. So that's why the whole mess up happened. So my apologies for that. So today I'm going to give you a quick walkthrough about a current hot topic dealing with Industry 4.0, data science, and Society 5.0. So I guess all of you are very familiar with the concept of Industry 4.0, the fourth industrial revolution, where we see manufacturing taking over in a very big scale with the help of artificial intelligence, virtual reality, augmented reality, various computational platforms, robotics, you name it, all the technologies under this umbrella. The core idea is to take manufacturing and automation to a very new level. And data science, on the other hand, we have AI, data sciences, all these various technologies matured during the last 20 years. And apparently the key idea is how we can utilize all this to the benefit of the community, right? We have technologies, we have various frameworks. How can we make use of them for the benefit of community? Or in other words, in the Far East, like Japan, they call it a Society 5.0. Okay? So I will, quickly walk through what is Society 5 and, like what are some of the major challenges from an AI perspective. So I'll go through Industry 4, Society 5, data sciences, followed by some conclusions. I guess I'm only given like 20 minutes, so I'm very sorry that I have to really rush through my presentation. So I guess if you go back to...
Sorry, sir, to disturb you in between. We can see your screen, sir, but the PPT is not visible, actually. So,
PPT is not visible?
no. So we can see your screen, by the way.
Okay, just a minute. So I'm not really sure what is going on, because my PPT is on my screen, so...
Sir, try sharing the whole screen once, because sometimes when we share only the file, it does not appear.
Actually, I tried the whole
Stop
screen.
sharing and then try once again, sir. Yeah, share the whole screen, sir. Yeah, entire screen once again.
Are you able to see now? It's coming up.
Yeah, you are presenting, but the PPT, can you open the PPT, sir?
Yeah.
Yeah, now it is visible. Now it is visible, sir.
All right. Okay. So let
Thank
me
you, sir,
just...
and sorry for disturbance.
That's okay. So if you look at the fourth industrial revolution, let us go back to the first revolution. We started in the 18th century, where we used mechanical and steam power for basic automation. And then with the invention of electric power in the beginning of 20th century, we are able to automate things in a very big scale. We call it a second revolution. And the third revolution goes back to the beginning of the 70s, where we try to invent basic electronics, fundamentals of information technologies, and various allied things. We are able to develop embedded systems. I would say automation in a big scale compared to the previous two. And today we call it as the fourth industrial revolution, where we see a networked world, where we have Internet of Things, cyber-physical systems, various other computational framework, AI, data sciences, robotics, uh, various realities, augmented realities, virtual realities, uh, various computational platforms for managing the various computational tasks, etc., etc. So this is actually a summary of the four industrial revolutions. So coming to Society 5, how the Japanese see this is slightly different. Actually, basically the first two, Society 1 and Society 2, basically it is not part of Industry 4.0. They start with the birth of human beings, then they are looking at the agrarian society, where people try to use various irrigation techniques for agriculture and like for basically for survival, for automation for survival. is like 13,000 years before Christ. So it's a long history. And while the Society 3 is very similar to Industry 4.0, where we start with invention of steam locomotives for mass production. And Society 4 is very similar to Industry 3.0, where we try to link with computers and information technology, automation in a very big scale. And finally, we are looking at Society 5, where we consider all these technologies, how we can utilize it for the benefit of the society in a very big scale. So if you look at various aspects, for example, we have like we are flooded with data, and then we don't have time or efforts to resources to analyze them for knowledge. So basically, imagine if you have nice methodologies to analyze these massive various forms of data and try to make meaningful knowledge. Imagine, like sparing humans or human beings from doing tedious, laborious works
Sorry, there is
using.
some issue from your side. Your voice is not clear.
Voice is not clear?
Yes, sir. Now it's fine.
Yeah, I guess it is a network issue. I'm not very sure. So,
Sorry, sir, for disturbance.
yeah, it's okay. So imagine the massive, like the the efforts, if you can channel to relieve the immense of work done by humans in various aspects. Okay, so that is towards Society 5, how we can relieve the laborious work, how we can relieve the laborious data load, how we can relieve from various social issues, pondering all of us communities, aging. So how we can use modern technologies to help those aspects. So if you look at current information society, like we will see a lot of verticals. Okay, so basically you search for something in the cloud, and then you get some lot of information, and then you again filter a lot of things, and then get information from that, and then again you have to search for something, then again vertical, the information flows in verticals, and then it goes back and forth, right? So basically the idea is whether we can share this massive information also in horizontal platforms, so that the amount of the way we will interact with the system would be as low as possible. So that is the basic idea. Okay, so we're using various technologies, artificial intelligence, data science, various sensor technologies. Okay, uh, how we can connect verticals and horizontals, so that automation could be taken to a very very new level. Okay, that is the basic idea. And the basic idea is to improve comfort, vitality, and provide high quality lives within the Society 5 framework. So basically, the whole idea is to improve our well-being in society, from like different classes. For example, people living in the villages, people living in the cities. At the same time, doing various tasks, laborious works, automated works, white-collar jobs. How we can enhance the quality of life by providing the best comfort as well as improving vitality. These are, I would say, the summary of Society 5. And if you look at data science in a big scale, recently we are seeing data of different forms and coming at different speeds. So we look at volume, velocity, data streams, variety, structured data, unstructured data. For example, if you look at social websites, for example, like Twitter or Facebook or LinkedIn, all these various networks, you see data coming from various forms. Veracity, sometimes we're not even sure whether data belongs to a particular sensor bed or a particular network. Could be even, you might have to deal with uncertainty, imprecision, vagueness. Okay? So challenges are also, like at the same time, several folds. And there are also various methodologies for handling big data, from Hadoop to MapReduce for basic handling of large volume of data, to big analytics, using various tools, off-the-shelf tools, commercial libraries. Okay. Then if you want to have deep insight of the data, then we need to customize. For example, if you have 1 million tweets, and if you want to summarize what is behind this massive volume of tweets, then we need some customized methodologies to improve the knowledge that you obtain. So if you have 1 million tweets, and if you want to find what is sentiment from these tweets, what is summary of these tweets, or let us say a WhatsApp group, you have like you have an election night and a lot of conversation going on, and you don't have time to read the entire conversation. You want to find what is a summary of this conversation, of these 1,000 people exchanging information over a night. What is summary? So then we need to customize various methodologies to understand what is going on. And in AI or data science, we call like understanding patterns. And patterns can be different forms. For example, from iris detection or fingerprints, face, uh, to voice or signatures, or the way we move our hands, the way we walk, gait movement. So it could be anything. Okay? So understanding patterns means we are able to find something from the particular data or that information. So typically what we do in the machine learning AI is that we try to train a model, we develop a model, and then we save the model and we test the model using another set of data set, which is not seen before. And basically then we see the errors, and then we try to link how the training error and testing errors are, and if they are compatible, we say that the methodology works well, or we need to tune the model, or we need to find some other model, etc. And in typically machine learning, we deal with a few different classes of problems. For example, one is functional approximation, where we deal with regression, classification, pattern recognition type problems. For example, given like features of something, and then you need to classify it is like this, or given today's weather, what will be tomorrow's weather, or given some uniform pattern, our task is to classify whether uniform belongs to Army, Navy, or Air Force. Okay. Some patterns. So it could be various ways how we can deal with machine learning problems. Another area is approximate reasoning, where we try to deal with vague information most of the times. So in real world, many a times the precision doesn't work, and sometimes we don't have enough computational resources to make good decisions. So the idea is to make approximate reasoning methods, or such schemes which can deal with vague or imprecise information, and still we are able to get sort of useful or important decisions in real time. So I would say decisions that would work in real time. So we would try to use approximate reasoning for various. Another big area in the field of AI is the field of optimization, where we try to do things better. For example, you have a model, you need to make it better, or you have a system, you want to tune the parameters, okay? Or you want to find the shortest path from one place, another place. Could be useful in networking, sensor networks, okay? Or in supply chain management. Or you want to find the shape of an aeroplane, what is the best shape of a wing, the shape of a pen. And many times we don't know what we want. So we are dealing with what we call as solutions which we are not aware of in front. So we just have some vague information about what we want, and then we ask system to find what are the best possible solutions. So typically within a AI context, I would say these are some of the main components. We have various probabilistic models for dealing with uncertainty. Then we have various set theoretic models dealing with various imprecision, etc., like fuzzy logic, rough sets, near sets, etc. In functional approximation, we have all these machine learning models, neural networks, decision trees, support vector machines, various other learning methods. Randomized search, or I would say global optimization, we deal with various uh, evolutionary computation, swarm intelligence, or various meta-heuristic methods. Okay. So I guess all of you are very familiar with neural networks, or at least have some basic knowledge. So basically, 50 years, 60 years age research. So from simple backpropagation, today we are looking at deep learning networks, where the idea is to learn high-level features at these layers. so that each layer learns some high-level features of the previous layer. Something which we humans we typically do, and typically, depending upon the number of neurons, number of layers, we can also actually construct a very nice decision boundary. So if you use 3 neurons, you could see that, and if you use 20 neurons, you could see the difference. So basically, you can actually create islands of decision boundaries when you have more hidden neurons. And one way we look at this is to deal with what you call as flexible neural trace. So basically, typically we don't have the time and efforts to look for the number of neurons, the number of layers, the architecture, parameters, the learning method. So we formulated a methodology called flexible trees, where we just need to specify the basic, the fundamentals. Means that the input you have and some sort of the structure, a vague defined structure. The system automatically designs what you call as neural trees. See on the screen, and the system automatically also picks up the required features and build the trees. And just to give you a flavor, you can see that there's some comparison between previous works and our tree work. So basically, you could see the last 2 rows. So this is for gas furnace time series. So by injecting time lags, you could see that by injecting 5 time lags, you could see the errors reduced by 50%. So what I want to say is for time series forecasting, if you inject some time lags, which typically many statisticians do, basically can improve your performance in a. This is for some benchmark data sets, leukemia, colon cancer. So you could see that the flexible trees are working very well. So typically what happens in a flexible tree approach is we have a population of trees, a population of final solutions. So we have a small tree which is not very accurate, or we have a big tree which is very accurate. So typically we have what you call the trade-off between accuracy and complexity. And in the case of neural networks, we also know that we have a diversity of activation functions that also helps to improve the performance. So we try to formulate this as a multi-objective optimization problem. So we have complexity, accuracy, and diversity. So we try to plot this in the Pareto front, and we try to find the best solution from that. This is actually some summary of some results for classification, some benchmark data sets. And this is actually the wine data set. It has 13 features, 30 plus features. And you could see that it only needs 5 features for particular classification problem. Similarly, we can also use it for regression problems. So this is again some regression benchmark data set. You could see the performance seems to work very well. The last part, I guess I just need another 5 minutes or so. So approximate reasoning, as I mentioned earlier, fuzzy logic forms a very important role within approximate reasoning methodology. And typically, what we need for building a fuzzy expert system is we need to encode the rules. We need to define input variables, the linguistic values for each linguistic variable, number of linguistic values for each linguistic variable, and various operators. Various things need to be done, especially if you have a large number of input variables. Typically, it is very difficult to design a fuzzy expert system in practice because of the problem of cursor dimensionality. So what we try to do is we try to call as a hierarchical fuzzy system, where we try to break the rule base into small rule base, and then we try to interconnect them. For example, if you have 4 inputs, it can be like this: A, B, C, or D, and much more. And imagine if you have 1,000 variables. Imagine the massive layers and interconnection. So it becomes an NPR problem, and then we need to formulate some optimization method for this. So we try to use a very similar method like the flexible trees here again. So user has to specify input variables and some basic operators. The system automatically design what you call as trees, which we can map as what you call as hierarchical fuzzy tree. What you see on the left side is actually fuzzy systems. You see each tree, A, B, C, D. These are all 3, 4 different fuzzy systems, hierarchical fuzzy systems, interconnected like this. And imagine if you have some search process, you can easily explore various combinations. That's the basic idea of this flexibility approach. And using simple operators, you can actually explore the search space very easily. This is for iris data, so you could see that it has 4 features. So using only 3 features, we can get 100%. And we also have an interpretable AI model. This is a wine data, so using only 4 features, 5 features, you're getting almost 100% accuracy. So again, we have the same problem like I mentioned earlier. We have a small tree which is not so accurate, or we have a big tree which is very accurate. So again, we have the problem of making a decision, optimal decision, or I would say a choice between complexity and accuracy. So it is very difficult to have both together if you use traditional methods. For example, you have a big tree or a small tree, you don't know which is the best. So you have to try, like back and forth and see what's the best. So we try to formulate this as a multi-objective optimization problem. So we try to trade off between complexity and accuracy, and we also try to evaluate type 1 and type 2 for this system. The type 2 for the system helps us to encode imprecision in a very big scale. So we are able to model imprecision much better in a type 2 system. So if you look at here, type 1 single objective, multi-objective. See, the error is reduced from 0.0043 to 0.0041, and you could see type 2 single objective, type 2 multi, you could see the error is again like this. Okay. And this is another problem, type 1 single, type 1 multi, type 2 single, type 2 multi. So you can see that from type 1 single to type 2 multi, error is almost reduced by a few folds, 0.0115 to 0.0032. So coming to a practical application, this has 300 features. Imagine if you have 300 features, imagine if you have 300 input variables entering a fuzzy expert system. You have 2 linguistic values per input variable. You have 2 raised to 300 rules. Becomes very impractical. Using this fuzzy hierarchical fuzzy system, which I explained just before, you are able to have a very compact model. So if you use type 1 model, you have a model like this. If you have a type 2 model, you have a model like this. You only have 4 variables. So from 300 variables, we are able to reduce to 4 variables and have a very compact model. On, so a very compact fuzzy system, which you can actually deploy in any environment. For example, in a mobile environment, or where you need some interpretable AI model, which could be able to also describe why I got this solution. Compared to neural network, there is one beauty of fuzzy expert systems. So typically, we are able to justify why we got the solution. So to conclude, I would see future there is a lot of convergence between cyberspace and physical space. We already have very nice frameworks for cyber-physical systems, Internet of Things, altogether various technologies connecting. And I'm sure that AI and big data will definitely sync together, make robotics and things take us to a brand new level. From an AI perspective, data science perspective, we still need a lot of methodologies for fast learning, achieving global error rate, also computationally inexpensive as well. Finally, I think we also need to spend a lot of time on understanding the problem as well. Because many times we don't understand the problem very well, and we try to use methodologies, complicated techniques, and then we say that this technique doesn't work. But basically, the problem is the data itself, the problem itself. So more time we spend to understand the problem, we'll be able to build a better model. So with that, I will conclude my talk. Thank you for listening, and if you have any questions, you can ask me now, or you can also email me. My email, I guess, is on the first slide. I guess.
Any questions from the audience? sir, we are running short of time, so we are cutting the questions. There are no questions from the audience.
All right, perfect. Thank you so much.
Thank you so much, sir, for enlightening us with your insightful address. Finally, we have our last speaker. Finally, we have our last speaker, Professor Mohammad Abulesh from Department of Computer Science, South Asian University, New Delhi. We are thrilled to have him here. I invite Professor Abulesh to share his knowledge with us.
Okay, good afternoon, and thank you very much for inviting me here. And generally, whenever I get any invitation from AMU, I I I, I accept it, and I always be happy to come and try to share some of the works that we are doing at Jamia or South Asian University. Uh, it's very good initiative. Generally, having a conference on this emerging computational intelligence, and I hope department is going to carry on as a annual event or biannual event, because if you see the pace of development that is going to take place in this computer science field, like just before 4 or 5 years we noticed this emergence of deep learning techniques and the way it penetrated into various domains, and the way it started solving various problems that we were engaged with. And just now you might have listened about this chat GPU and the revolution that is going to bring, and many people have started thinking like, is it going to replace human? Is it going to replace writers? Is it going to replace paper writers or whatever? And obviously you might have noticed various publishers are thinking about it, like how to differentiate original research papers from those that are generated by chat GPU or other large language model techniques. So in this pace of development, if you just leave research, or you can say be out of touch for few months, you can realize like it would be very difficult to carry on further. Okay, so accordingly, I just decided to share some of the work on social bots, key enablers for emerging threats in online social networks. And I would be very abstract in this talk, mainly to highlight open challenges, opportunities, and research directions. This would be brief agenda, some introduction of SAU and LDSA research group, then data deluge and related challenges, online social network and their characteristics, because online social network is one of the platform where we can find out a huge amount of data that is varied in nature and that is dynamic in nature. Okay, so nowadays you can see this online social network is being used for varied purposes, even intelligence, or you can say business or profiling. So there are so many domains where OS and data is being used, and but along with its advantage, there are so many other, you can say, disadvantage also. There are some, you can say, misuse of this platform also. So social bot is one that is being used for various malicious purposes. I would like to highlight like social bot. What are they? What are these? What are the challenges? What are the threats? And what are the things, or what are the ways to just try to identify, or you can say detect social bot? I had one student from this AMU computer science department itself, Muhammad Fazil. When he was JRF qualified, he went to Jamia, he joined PhD with me, and he has started a work on this social bot detection. And nowadays he is in Ireland doing some postdoc with very strong research group. So this is the work that I am going to present some at very abstract level, not going into much detail. But you can realize like how challenging this problem is, and how these social bots are being used by various parties for different malicious purposes. Then of course, once you try to identify social bots and its challenges, its characteristics, the task is how to detect it in an automatic way, or you can say as early as possible. This is very important. Otherwise, if you are delayed in detecting social bots, it may create so much harm to society. And finally, I would like to conclude the presentation, followed by some directions of research. So this South Asian University, this is established by all 8 SAARC nations. Earlier we were in this Akbar Bhavan, but after 10 years, just now we shifted to Maidan Ghadi, that is 100-acre campus. So it was very challenging task during my registrarship to shift this university from Akbar Bhavan to this Maidan Ghadi. And that is a very large project of this Ministry of External Affairs, Government of India. So they have constructed almost 50% of the buildings, and very soon in next 4 or 5 years, they are going to complete this whole campus. Very state-of-the-art buildings and infrastructure is going to come, and it's going to flourish very fast, you can say. And here the beauty is we have half a student, or 50% from India, and 50% from other SAARC nations, including 10% from out of SAARC also. And the purpose is just to bring students from all these neighboring countries, let them to be together. So in hostels also we try to put one from Pakistan, one from India, or you can say one from Bangladesh, one from Nepal, so that they could live together, they could understand each other, and once they go back, they would be ambassador of these SAARC nations. So it's very unique in nature, or you can say this is Nalanda of 21st century that this government is trying to establish. Recently we have only masters and doctoral programs in 7 departments, including computer science also. At this department we have 6 faculty only. Out of them, I am the one, and I am leading this data science and analytics research group. And I have a small research team, including myself, Professor Jackie. He is a well-known personality in the field of data mining. One Professor Naidu Subbara from JNU, just for working on this biological part. Tariq was my student, or you can say my researcher at Saudi University. He went to Australia, he did his PhD. Now he is in UK. Fazil, my student, and some postdoctoral fellow, and PhD students and masters from South. So this is a small research group that is leading this, who are working in this data science and analytics research group. And if you see trending 21st technologies, SMAC is one, you can say, like social computing, mobile computing, analytics, cloud computing. So our research group is mainly focusing on social computing and analytics. We are not touching this mobile computing and cloud computing. So these 2 are major research areas we are focusing on. And whenever you talk about data science or data analytics, data is one of the important component. And it's, you can say, this is the oil of the digital economy. So this understanding data from various perspectives is very important. Data could be in different form. It could be structured, it could be unstructured, it could be semi-structured, depending on the source where data is embedded. Like if you talk about a text file, this is an example of unstructured data. If you talk about a XML page or HTML page, this is an example of semi-structured data. And if you talk about an Excel sheet, or you can say database table, in which each bit and byte is fully tagged, like table headings are there, then under that heading, whatever data is recorded, that is basically, you can easily identify. This is name of the person, this is age of the person, this is date of birth, and so on. So, and another way is depending on type of data we are going to analyze. Like it could be numeric, it could be nominal, it could be images, could be video, and you might have observed like whatever companies are there, they have two different types of data. One is internal data that can be analyzed for various purposes, management purpose, or you can say optimization purpose. And similarly, there are external data also. Like suppose any product is coming in the market, so companies are trying to see and go on social media what people are actually talking about those products. What are the features that are liked by the customers, and what are the features that are not liked by the customers, so that in future version you can try to target those features that are liked for upping the sale, and those that are unliked by the customers, that can be improved also. So there are different types of data, internal, external, and they can be analyzed for various purposes. Some examples are here: upsell, cross-sell, improve customer service, and retention rates. And of course, along with data, this data pre-processing is becoming a very huge, or you can say challenging task, because nowadays whatever data is being generated, it's totally in uncontrolled manner. And if suppose data, and you might have seen at the very earliest stage of computer science when we were studying, garbage in, garbage out, it was very common. If suppose wrong data is going, and whatever algo you are applying, wrong output is going to come. So whatever data we are going to capture for analytics purpose, or you can say for decision making purpose, that data must be correct from all perspective. So data pre-processing is very, very important. At the last point, you can say data accuracy is critical. And one example is there: NASA lost $125 million Mars orbiter, and there was minor error in data. Just this unit was different, and due to that unit error, this was the loss of this NASA that happened. And this is basic difference between traditional data and big data, or you can say in traditional approach, generally we have a hypothesis in mind, and around that hypothesis we try to create some experiment, and through that experiment we try to generate data, then we try to analyze it, get a result. If result is not up to the mark, then we can repeat this cycle. So in traditional approach, data is always controlled, and there is less chance of erroneous data, or you can say inconsistent data. But if you talk about new science of data or new trend of data generation, so we have process experiment. Like this Twitter, this is a kind of process, you can say. This is a platform. Anybody can go and join, anybody can start tweeting, anybody can start following. Similarly, Facebook, this is an open platform. People can start joining and writing comments and liking and making friends and so on. Similarly, if you install a camera, whoever is crossing through, it's going to capture the pictures and other things. So in new science of data, we have process experiment, and it's going to generate lot of data. So this is basic difference between traditional and big data. So we can say data everywhere, nor any drop of insight. Like in mobile phone itself, you might have seen 64 GB, then 128 GB, then 256 GB, and again after some time you need to clean it. So much data is coming even on your mobile phone also. So if you see the challenges here, so data exists in various modalities in the form of tables, images, video, audio, text, hypertext, semantic text, networks, a spreadsheet, multilingual. So these are, you can say, modalities of data. They are enriched. If you try to model it in the form of some structure, so we can talk about weighted graph, we can talk about multi-leveled graph, we can talk about temporal graph, or we can talk about a spatial graph, or we can say we can get a graph where node and edges can have different types of levels. Okay. And of course, it is dynamic in nature. Every second you can see how many people are joining the Twitter. Every second how many people are tweeting. Every second how many people are starting following some other users and so on. It's obviously it's not at one platform, so that you plug any device and get data. It's on distributed platform across the globe. Uncertainty is there because data is not controlled from different perspective. And of course, we are talking about terabyte data and petascale data. So if you talk about challenges here, so one challenge is data is not independent, rather it is linked. So if you see this Facebook data, we have users, and if you take a pair of users, they are friend of each other. There could be a link based on friendship. Similarly, on Twitter also, users can be at the nodes. Then one is following another, so there could be a link of following kind of things. Or you can say two users are having same interest, they are liking the same things, so there could be an age. Okay. Even you can say, if you talk about database table, and suppose there are 4 attributes in the database table, so each record can be a point in 4D space. Then depending on relationship, or you can say similarity between the records, you can easily plot the ages between the nodes. So even tabular data can be modeled as a graph. So this is one challenge. We don't have only values, rather those values are interlinked, or you can say interrelated. So traditional notion of independent data item is increasingly false. Everything is linked. Many data sets can be modeled as complex attributed graphs with various attributes on nodes as well as ages, and they can be labeled as text, time series, or confidence, or whatever. And these are some examples of networks like social networks, biological networks, communication networks, mobile ad hoc networks, and so on. So here you can say graph everywhere. Second challenge is if you have data in the form of graph. Suppose you have data that is modeled in the graph, and if you talk about mining this graph data, so it has its own challenges. But one of the well-known challenges is how to deal with isomorphism. Like in this case, you can say like left side and right side. So structure-wise they are different, but these two graphs are almost same, or you can say they are isomorphic to each other. So it is going to add too much complexity while dealing with graph data. So this is another challenge. So where are we headed? Into the mouth of scalability and complexity beast, because hardware has its own way to improve its processing power and memory storage capacity. So we are moving towards scalability and complexity beast. Due to emergence of complex data and graphs, they are enriched, weighted, multi-labeled, and temporal, distributed, uncertain, dynamic, massive, and unbounded. And of course, you can say networks, and more networks. Online social network is one example where data is being generated in uncontrolled fashion, but it's very useful also. Otherwise, earlier you say, if you want to perform any survey, then of course you try to prepare some questionnaire, then try to target some audiences, give your questionnaire, take their response, then put into your machine, then try to analyze it. But nowadays, simply go to online social media, write some small code of crawler, then you can try to dump data, whatever you want, then you keep on analyzing it. So online social network is one very, you can say, useful platform. Data are being used by various companies and various users for different and varied purposes. So social network, if you try to define it in a very nutshell, you can think as a simple graph in which we have nodes and we have edges. Okay. Nodes are nothing but it could be persons in case of Twitter and Facebook. It could be computers in case of internet. It could be other things also. In case of like biological domain, it could be molecules, and edges could be their interactions and same kind of things. It could be genes, it could be proteins, and other things. So in a nutshell, you can say this is a simple graph having set of nodes and having set of edges. And edges may be different depending on what kind of data you are going to model. It could be friendship, it could be acquaintances, it could be interactions, it could be co-purchase. Why social network is important? Because they help to model the various processes taking place in nature and society, like a spread of cultural fates, diseases, computer viruses, diffusion of information, recommendations, and gene expressions. So these are few examples where social networks are very important. If you try to compare general network along with social network, So social network has unique properties. One basic property is a scale-free power law degree distribution. And this says fraction pk of nodes having degree k is approximately given by power of k, where that is pk equals 1 upon k power y, and y is generally a value between 2 and 3. So this is basically 1 upon k square. If you take y as 2, 1 upon k square, if it means what? If you increase the value of k, the whole thing is going to be down. In other sense, we can say in Twitter, you can see there are very few users who are having so many followers, but there are too many users who are having very less number of followers. Okay. So graph-wise, you can say, if you see this graph, on x-axis number of links, on y-axis number of nodes with k links. So there are too many users in the network having less number of links, but there are very few nodes having so many, you can say, followers or links and so on. Like celebrities, you can say 1.5 million followers, 2 million followers, and so on. But there are so many so many users having 10 followers, 100 followers, 1,000 followers. So this is called power law distribution. Second property is assortativity. So here the point is, generally in a society, people with same status try to be friend of each other, or people with, you can say, same societal status, they try to be friend of each other, or having in the same profession, they try to link with each other. So in social network also, we try to find out this kind of pattern, like those nodes that are having same degrees, they are linked with each other. So this kind of pattern is there. Like here you can say, if suppose A equals 0, assortativity is 0, in this case each node is going to be connected with each node. But if you keep on increasing, A equals 0.26, you can say some sort of sparseness is there. If A equals 0.43, then you can say like high degree nodes are connected with each other, next high degree nodes are connected with each other. So this is found in social network. Third is, in social network, you can find out various clusters kind of things. Not all nodes are equally connected with all other nodes. Rather, you can find out one hub in which all nodes are densely connected. You can find out second group in which all nodes are densely connected. So they are basically going to form some sort of community. Like those who are academics, they try to connect with each other. Those who are in politics, they try to connect with each other. So this kind of structures are found in social network. Similarly, a small word behavior, like if you take any two node, this is hardly 6 hop distance, add 6 hop distance. So in a social network, if you take any two nodes, their distance is hardly 6 hops, not more than that. Contagion is there, like in society also, if you are in touch with some bad people, there is a chance you are going to inherit some bad habits. If you are in touch with good people, there is a high chance you are going to inherit some good habits. So in social network also, with whom you are communicating, with whom you are chatting, it also impact your ideas and other things. And the last point is structural holes. In social network, there are some points that are very critical in the network. Like on left side, you can say this A node, this is going to connect 3 sub-networks. So this A is very important point. This is called a structural hole. And this A can be, you can say, monitored, or you can say can be used if you want to pass something from this network to that network. Okay. So these are 6 basic properties that are present in social network. And whenever you talk about analyzing social network data, you should keep all these properties in mind that are unique to online social network. So why social network analysis? Because it allows users to define and maintain social relations, nothing to do for this purpose. It's very open platform, and a large number of population is on the network. So they keep on defining and maintaining social relations. Find and link to other users with similar interests. You can easily find out communities who are interested for a particular product, or you can say for a particular purpose. They keep on sharing, finding and endorsing content. So these 3 are main reasons for network analysis, because these are some automated process and nothing to do for this. You have a large user base, simply you can try to get those data and you can try to analyze for your purpose. So it's very extremely popular, huge membership, and enormous amount of social network data being generated. So these are the purposes behind social network analysis. And if you see some data mining task data related to social network analysis, one is this social network modeling. So this is itself a open area. One can work on this part. So many network models are available. One can have a look on those models. They can try to see how more efficiently the data can be modeled further. Link prediction, like between a pair of nodes, what is the probability that they are going to be in touch in future, or there could be a link between these two people. So it's very well known, well defined problem in social network analysis, link prediction. Similarly, information diffusion. If you try to put some information in the network, how fast, or you can say how much time it is going to take to be diffused in the whole network. Opinion mining and sentiment analysis, it's very you can say well known or well established problem. Influential node mining, it's very important from marketing perspective. Like suppose in a social network there is a new product, you want to just fuse in the network, you want to get it market it, so no need to give a sample to each and every person. So in the network you try to identify what are the influential nodes or who are the influentials in the society, then try to give a sample to those persons or those nodes. Once they are addicted, or you can say once they are habitual to use this product, or you can say once they are convinced to use this product, there is a high chance they are going to influence their society. So this is called influential node mining. Community analysis, it's very, you can say, well established problem, and so you can say more than 1,000 algos are there in the papers, and these communities can be analyzed for various purposes. Open source intelligence, this is being used by various intelligence agencies. And in many cases, like any crime is happening, they are trying to get your call records. So basically they are trying to generate a network kind of things. So you have one mobile number, then to whom you called, to whom they called. So they can try to move 1 hop distance, 2 hop distance, 3 hop distance, and they can easily find out like what are the users that came into contact before this particular crime. Similarly, on weblog also, they try to see like before this crime, doing this crime, what kind of product you explored, what kind of websites you went, what kind of analysis you made. So it's very popular application of social network analysis for open source intelligence. And obviously social bots detection, like nowadays it's very frequently being used for various malicious purposes, mainly during election kind of things, or you can say just to influence others, or you can say just to embed something in the society. So they are through social bots kind of things. So if you talk about social bot detection, so this in nutshell, social bots are computer programs to handle profiles in online social network and mimic human behavior to pass as human being. Okay. So they are basically a software kind of things, or you can say programs, automated programs, and they are trying to mimic as a human being, and once they are entered in the network, then they try to cheat other users in the network. And if you talk about social bots network, so this is a group of social bots under the control of a single bot master, because they have to they have to steal genuine users. So before going to genuine user networks, they try to create their own network. Then they try to create some sort of trust and other things in the network. Then try to go to those users who are actual users in the network. So this is common architecture of social botnet. And if you try to compare with web botnet and social botnet, they are almost very much similar. In case of web botnet, we have a bot master. We have servers as command and control channel, and we have various bots can be injected in those servers, and they perform some malicious activities, and they are going to infect your computers that are in the internet. In case of social botnet, we have bot master. Online social networking platforms are command and control channel. They are being used as command and control channel. You can inject your social bots. They are going to perform various malicious activities, and the targets are here users. So this is basic difference. In case of web botnet, targets are those computers that are on the internet, and in case of social botnet, The target are users who are the member of your social network. Here is just in a tabular form from different perspective, like from bot perspective, web botnet, this is compromised computer infected using malware. In case of social botnet, this is OSN profile operated by software and emulating human behavior. In terms of botnet, in case of web botnet, this is group of bots controlled by a bot master. In case of social botnet also, this is group of social bots controlled by a bot master. In both cases, bot master is almost same. They are going to control bots in the network. And if you see command and control channel, in case of web botnet, it is basically various communication protocols. It could be telnet, IRC, P2P, and so on. But in case of social botnet, they are nothing but online social networks. If you see threat dimensions, in case of web botnet, it is network and host hijacking. This is one example of threat that is associated with web botnet. Distributed denial of service attack, spamming, information stealing, and so on. In case of social botnet, it could be astroturfing, propaganda diffusion, spamming, bullying, information harvesting, and so on. From threat aspect, space point of view, in case of web botnet, it is internet including private, public, government networks. In case of social botnet, it is restricted to only online social networks. And if you see attack technique, in web botnet, exploit software vulnerabilities and social engineering. But in case of social botnet, it's only social engineering kind of things. You might have heard various news in newspapers like social bots distort the 2016 US presidential election. So it means there is presence of social bot in the network. So these news are going to authenticate like social bots exist in various real online social networks. Similarly, you might have heard about Facebook and Twitter are being used to manipulate public opinion. There was a report. Similarly, political bots spread misinformation campaign in this US election kind of things. So these indicates social bots are real. They are not hypothetical kind of things. They exist in social network and they are being used by various parties for various purposes. So this is another news about social bots. Now if you try to see threat due to social bots, the social bots are being used as political tools. You might have noticed during last few elections in few years. The social bots as political tools, social bots as fake news distributors, social bots as infiltrators and influence manipulators, and social bots as spammers. So these are different threat dimensions that are due to social bots. And if you go to further details, like social bot as a political tool, so this is being used for astroturfing, fame fostering, opinion manipulation, rumor spread, misinformation, disinformation, hoax. Similarly, social bot as a fake news dissemination, this is being used for opinion manipulation, rumor, misinformation, disinformation, hoax, satire. Social bot as a spammer, clickbait, content pollution, advertisement, malware propagation, spear phishing. Similarly, social bot as an infiltrator, it could be stalking, spear phishing, spoofing, identity theft, follower trapping. So you can easily, like those who are working in terms of cyber security or information security, they might be aware about these terms. So these are different dimensions, and these are the particular threats that one can encounter once you are a member of online social network. And this is the impact of threats created by these social bots. Mistrust may lead apathy among users, political destabilization in a region, prevalence of fake news, pollution of the online social space, privacy violation, and identity theft. So if you see present scenario, 20% of users accept unknown friends request, 7% of tweets are spam bots, 15% are not human, and 30% of users can be deceived by chatbots. Okay, so these are the present scenario of this online social networks and users. And future, of course, is going to come like me, click me. You might be seeing people are making a small video, try to subscribe, try to click on bell icon, try to like me and so on, just to increase their user base and subscription base. And of course, after some time, they are going to get some reward also. So it's very common trend nowadays. So if you try to see from research perspective challenges in social bot detection, so one is individual-centric characterization and detection approaches, analysis of problem from target user's perspective rather than a social bot perspective, absence of online-offline identity binding. Like generally if you go to Twitter, try to see user ID, using user ID it is difficult to identify who is the person. So there are so many, like it is very difficult to bind your online and offline identity, absence of adaptive detection system. So this is some sort of cat and mouse game. There is a kind of social bot, you try to propose some algorithm to detect it. After some time, that will be immune to this detection technique. So there should be some way to automatically adapt detection approaches and keep on improving for detecting social bots. Our contributions, basically this what Fazil did on his PhD, experimentally observed the infiltrative performance of social bots among different regional users. So he had selected 6 regions. He tried to inject real social bots in the network. 98 social bots were there. Then he went for characterization and profiling of users who are trapped to social bots, evolution of the users in online social networks, and characterization and detection of social bots in Twitter. So this was basically a summary of work that he performed, and accordingly this was the framework. So leftmost part was basically social bot injection, data logging and pre-processing. Next part was social bot network analysis. Then it was user profiling and evolution modeling. And finally it was social bot detection and prevention. So it was in a, you can say, chapter form, and it was a graded work starting from injecting social bots in Twitter network to finding some ways to detect them and propose some methods for mitigating the effect of social bots. So he injected 98 social bots. They were able to run for 28 days. And of course, after that, Twitter, it was detected by Twitter, they stopped it. But by that time, he was able to log lot of data, so many followers, so many followings, and that was enough to complete his PhD thesis. So this is details about how he went for this experiment. I'm just coming to analytical part that he found. Okay, so this is like after logging data, he tried to analyze from various statistical perspective, and these are some conclusive point. Like social bots can easily infiltrate Twitter users. They are so programmed that they are able to infiltrate Twitter users. Infiltration performance of social bot is found to be related to their regional association. Okay, since we had selected 6 regions, so it depends on users, like which user belongs to which region, like Indian users, or you can say US users, or you can say this Arabic users and kind of things. Gender of a social bot doesn't play any significant role in infiltration. Profile attribute setting is impressive just to attract followers and other things, and following activity is found to be the most effective activity. So these are some findings of his analysis. Verified users also, blue tick users also, they are at the risk of infiltration because they are hungry of followers, or you can say, so there is a high chance they may be trapped by the social bots. So in our experiment also we found one blue tick users, verified user, he was trapped by our social bot. So verified users are also at the risk of infiltration. And in this generally what we found, there were fake profiles and malicious profiles. They are very easily, or you can say they are eager to follow anyone. So they were, whoever trapped by our social bots, most of them were basically fake profiles, or you can say malicious profiles. And similarly, topical analysis of trapped users' tweets revealed that benign users can also be fooled by the social bots. Okay, so these are the findings that he did. And if you try to find out detection techniques, so starting from a statistical way to determine some basic features and try to see whether this particular profile is social bot or benign. Even machine learning techniques are being used for this purpose. So in this work, we went through defining various features. We categorize the features in various forms: metadata-based features, content-based features, network-based features. Under network, it was interaction-based features, community-based features. These are some symbols we have used. This is a summary of features that we defined. Of course, research is always incremental kind of things in most of the cases. So we took the features that are being used by previous researchers. We tried to redefine some features. We tried to introduce some new features. So redefined features are 2, and there are 6 new features that we introduced. And here are the ways we defined those features, and we calculated from data, like how to identify various features from your data. This is data set we used for experimental purpose and for comparison analysis. So data set 1, data set 2. Of course, we use some machine learning algorithms, random forest, decision tree, Bayesian network. Evaluation matrix was detection rate, false positive rate, and these are the results you can say. If you take all set of features, approximately you can say detection rate, false positive rate for FS score. It is approximately you can say 95% plus. Then we try to apply some sort of evaluation analysis, like what is the impact of metadata-based feature on the social bot detection, what is the impact of content-based features on detection, what is the impact of interaction-based features, and what is the impact of community-based features. So out of these, you can say second last row, these interaction-based features are very important. Like if you try to remove these features from your feature set, then this all parameters, including detection rate, FS score, FPR, so mainly detection rate, FS score are going to be down, and FPR is going to be up. So so all those features that are based on interaction based, they are very important for social bot detection purpose. Here we tried to analyze this data for different ratio because such data is always imbalanced in nature. Very few are social bots. There are too many genuine users. So we try to see 1:1 ratio, 1:2 ratio, 1:5 ratio, 1:10 ratio. So we try to go for various type of imbalance ratio. Then what is the impact of these classifiers over social bot detection? Here is a comparison of our approach with Yang et al. Approach. That was a state-of-the-art technique. So in terms of detection rate, you can see we performed better than Yang et al. On both data set. In case of false positive rate, you can say our FPR is less than Yang et al. Similarly, in terms of FS score also, we are better than Yang et al. So this was the comparison with a state of the art, and finally this paper went to a transaction paper, and the beauty was those features that we redefined. So we redefined 2 features, we introduced 4 new features, and all these new features were mainly interaction based features. So here the beauty was, if you try to calculate features based on like user centric features, any user can manipulate its feature. Like I can manipulate my own features. If suppose I have various neighbors and my features are being determined based on their feedback and their things, so I can't manipulate them. So in case of interaction based features, there is a node, it has its neighboring nodes. Then using those neighboring nodes you can define the features, because that features cannot be manipulated by the social bots. So that was the main you can say gist of this work, and that caused this paper to go in a very you can say prestigious journal to get published. So if you come to conclusion part, social bots detection is like the cat and mouse game, as I told earlier. Like you try to propose a technique for social bot detection. After some time, the social bot is going to adapt it. Okay. So you need to analyze, propose next method and so on. And similarly, data unavailability and privacy issues are there. You cannot crawl everyone data and try to analyze it. And even if you analyze, you are supposed to go through various kind of ethical considerations before making those things in public. Identification of more robust features which are difficult to evade. Early detection of social bots, this is very important. And need more focus on adaptive and behavioral modeling based approaches rather than feature engineering based approaches. So future direction of research, we can talk about graph-based model to represent multi-dimensional social network data. We can talk about multi-attributed graph. You can talk about multi-dimensional graph. Efficient and scalable methods for large-scale social network analysis, big data analytics kind of things. Social bot characterization and detection. We can talk about data-driven cybersecurity. Trust estimation of social media posts, open source intelligence, mental health estimation via social media, especially this COVID episode. Now you can see lot of papers are coming just to analyze people mental health. Even you can say, if you see from medical perspective also, users are, or you can say people are started going to some sort of counseling sessions and so on. Okay. So this is very, you can say, emerging dimension of research, like mental health estimation based on the post posted by the users in social media, and of course business intelligence. This is being used since last 10 years. These are some of selected works of our research group that we have done. One was HOC tracker, tracking the evolution of hierarchical and overlapping communities in dynamic social network. So this is mainly on community finding and its tracking. Second was ranking radically influential web forum users. And third is a hybrid approach for detecting automated spammers in Twitter. Then a survey of figurative language and its computational detection in online social network. And just like in 21, this Fazil itself, he proposed deep SPD. This is deep network based model with attention mechanism for social bot detection. So you can go through these papers and all codes and data, they are on the website. So you can have a look, and if you have any queries, you can try to mail either Fazil or me, and we would be happy to assist wherever it is required. Okay. So thank you very much for listening and your questions.
Thank you so much, sir. Ladies and gentlemen, I heartily thank all our keynote speakers for sharing plethora of knowledge and their experiences with us. Now, I feel honored to welcome Professor Qazi Mazhar Ali for his presidential remark.
Assalamu alaikum and very good morning to everyone. Professor Asim, Professor Bukhari, Professor Tamanna Siddiqui, Dr. Shafiqul Abdi, Dr. Man Rasool Faridi, and the speakers of today's plenary session, dear students and colleagues. These three talks which have been presented are really need of the hour, and as a statistician I was just thinking at the back of my mind that basically it is statistics and computer science which amalgamated and gave the different names. Say for example, we were familiar with the word data, and then the large data, and then the big data. The differences of N and P. When N was large, it was large data, but now the new thing has come up, that is big data. And very simple definition of big data is this, that the data is large, that is not new thing, but the big data is different, that where the number of variables have become large. I mean, say for example, just 5 persons are there, but five individuals are there, and you have 10,000 characteristics of each individual. So the N is 5 only, but P is 10,000. So this is the big data, and this is a very big challenge. Okay, and but when that first speaker spoke on peer-to-peer networking. So from the research student's point of view, if you just think about this, I mean, the message from that talk, to me at least, was that he used distributed indexing. Say, for example, one of the topic was he used distributed indexing for telephony. He used a hashing technique, and then he came out with a new algorithm, and that algorithm has given him to make it commercialization. So here comes the point where you as a researcher can make your research saleable. You can earn money through this, and that's what the government initiative is today, that they want that our researchers should be industry linked. And increasingly this question is coming up in different by different bodies, by NAC, by UGC, etc., that they are asking that what your research is having a revenue generation. So I mean, those who are sitting here, they are the young researchers. They can get this message from this first talk that they have commercialized their research. And so the route is that first you identify a real question of the industry. Then develop an algorithm for that using theoretical base which you have got from your computer science and statistics. And then that algorithm can give you a prototype which can be sold in the market, right? So if you do this kind of, can say, define your research in these modules or in this pattern, you can succeed in academia and in the industry as well. And the next speaker who spoke on Society 5, he has, I think this second and third of Professor Bulesh was really frightening to me, that what the society is going to be. I mean, it looks that you, means the young computer scientists, are going to manage what we think as a social bot. I mean, social bot is playing the role, changing the mindset, changing the opinion, changing. I mean, it can be done positively and negatively. You can make use of its positivity for negativity. So negative use is frightening, but positive use are welcome. So again, but when I found out that in big data analysis and in AI, the words which are using is old classical regression and classification, pattern recognition, and all these techniques are coming from statistics. So what is missing these days, that generally the students, when they are rushing towards in the new emerging areas, they lose the strength of their base. So this fundamental tools which are there in this graph theory, in the statistics, classification, regression, and all these tools, these are the fundamental nature, and these should be understood very clearly, particularly for the researchers, which generally are missed. And for example, he has used a power law distribution, which is again a probability. So the probability and multivariate analysis and Bayesian analysis, these are the very key tools of today's research. So I congratulate Professor Asim and Professor Tamanna and Professor Bukhari and our team to organize this workshop, this international seminar. As I was just discussing with Professor Tamanna, that it was the last international seminar was conducted in 1997 in the Hamid Saif's time. I attended that, and after so many years, and we are having this international seminar, and I hope this will continue. And as yesterday in the opening session, the anchor said that we welcome you to ICECI 2025 as well. So I hope that will be a reality, inshallah. and it will be a continuity. And again, with this note that we should get these researchers, I mean these kind of seminars are organized for generally for the young researchers and for old researchers, but the young researchers should get this message that you have a place in the society provided you establish yourself by answering the questions which are raised by the industry and which are answered only through hard work of theory and practice. Applied research is a bit difficult. Theoretical research is difficult in different node, but it is difficult in the sense that you should have the very sound theoretical base, and at the same time you should know the applied area, application area where you are going to apply that, and you should know the pitfalls and the unanswered questions, and those unanswered questions are the research problem, and that research problem will be answered by the theory which you have learned and the programming which you have learned. So these skills are needed, and reading research is very easy today because of the availability of all the research material in the cyberspace. So I wish that you, with this hard work, you can succeed in your personal life, and it will be a success for AMU as well. Thank you very much.
Thank you so much, sir. Last but not the least, as we come to an end of today's plenary session, I would like to invite Dr. Shafiqul Abedin to deliver the vote of thanks.
A very good afternoon and Assalamu alaikum. On behalf of the organizing committee ICECI 2023, I am here to express my vote of thanks to Professor Qazi Mazhar Ali Sahab, a special chief guest for today's event. Professor Qazi Mazhar Ali Sahab, we are very thankful to you for accepting our invitation and for being here for today. Your minute technical observation and thoughts have totally inspired us. I extend my heartfelt gratitude to distinguished Professor Y.N. Singh for his admirable speech on cryptography and digital signature. Cryptography digital signature is still a challenging task for researchers, particularly for PG students and researchers. I am also thankful to our keynote speaker, Professor Ajit Abraham, for his extremely useful technical speech on Industry 4.0 meets data science pathway for society. Really, the talk was amazing, and it is the need of the hour. Professor Abraham is a well-known international academician and researcher. Many young researchers are inspired by his work and contribution. Professor Abraham has more than 50,000 citations into his credit. My earnest thanks to renowned speaker, Professor Muhammad Abulesh, Professor and Chairperson, Department of Computer Science, South Asian University. Thank you very much, sir, for delivering a keynote on social board. It was really a wonderful piece of information for latest trend in IT and research. I am equally thankful to my colleague, Professor Tamanna Siddiqui. I would also like to thank fellow students and everyone present over here for making this day a wonderful and memorable one. I would also like to thank our energetic chairperson and convener of ICECI 2023, Professor Asim Sabar Saab, for looking after day-to-day conferencing activities and planning the execution of conference. I am also thankful to Professor Muhammad Ubaidullah Bukhari for his valuable and practical advices. Lastly but not least, I will extend my gratitude to all the team members of Faculty of Science, Computer Science, any student as well. Thank you very much.
Thank you, sir. With this, ladies and gentlemen, this plenary session comes to an end. Thank you for your presence. Now I invite all of you over a cup of tea. Soon after the tea break, we will have the technical sessions as per the schedule.